Hi class, okay, so we continue with the second derivative test. But what I want to do now is I just want to proceed with the previous example 1 and 2 in the previous video. So I hope that you still have your the paper that you calculate just now. Okay, so back to the example 1. Okay, example 1 now is said just now in the previous video is said that determine the critical point of blah blah blah. Okay, so now I want to extend this example. Okay, this okay, we are using the same function. Okay, but I just extend. Okay, consequently. Okay, this is the word that I use just now. Consequently. Okay, determine whether the critical point have a local mean, local max, or saddle point. Okay, this is mean saddle point lah. Okay, saddle point means it's not either local max or local mean. Okay, so this is the extended from the example 1 question. Same function. Okay. Alright. So what we call it? Before we proceed, to this example, I will show you first the steps for second derivative test. Okay. Okay, I take out this one first. Okay. Second derivative test. Okay, so the objective, what's the objective of the second derivative test? Okay, if first derivative test is we want to determine the critical point. Okay, and now for second derivative test is we want to determine whether our critical point just now, okay, yang kita dah kira tadi, the critical point that we get just now, we want to check or we want to determine whether that critical point is local max, okay, local maximum, local minimum, or saddle point. So that's the objective. Why we do a second derivative test? Okay, to determine local max, local mean, or saddle point. Okay, so that's the objective. Okay, alright. So now, so this is how we find the or how we do the second derivative test. Okay. Alright, okay, now you can see that this is a modulus, right? So actually this is it's a represent what we call determinant. Okay. So determinant is some that we learn in matrices. Okay. So determinant. So inside the determinant here, we have fxx. We have fxy, same fxy also. This one is fyy. So you can see that they have fxx. So means that you differentiate twice. Twice kan? So it's related to what's the title here? Second derivative test. So means that you need to differentiate twice. Okay? So you need to differentiate fxx, fxy, and also fyy. And then after that you substitute into this determinant, this modulus ke matrix ke, to get the determinant. So how to find the determinant? If you still remember, it must be AD minus BC, right? So AD minus BC. Okay, so I don't want to explain detail on this part, so I just want to write. So fxx, okay, it will be fxx times fyy, okay, A times D minus B times C, so fxy square. Okay, right, so then you will get a value ataupun function, okay, because it can be still exist the variable x or y, okay, kat sini. Alright, then what we have here, we have 4 condition. Okay, we have 4 condition here. Let's just write here lah. Okay, the first condition, it said that if GAB greater than 0. Okay, this one GAB, right? So after you do it this one, you will get a value here, or maybe you will still get an unknown. Okay, but you will get something here. Okay, Alright, so if your GAB is greater than 0 and your FXXAB is also greater than 0, so therefore your FAB, so FAB means your critical point, okay, is local minimum. So the keyword here is this one and this one, okay. Alright, second condition, if your GAB is greater than 0 and your FXXAB is less than 0, therefore your FAB is a local maximum. Okay, so kat sini lah dia punya difference kan. So the first one is greater, the second one is less than. Okay, condition number 3. If your GAB is less than 0, okay, so now it's less than 0. Just now for condition 1 and 2 both are greater, okay. So if kat sini here is already less than 0, you no need lah to calculate FSX, okay. So you can just jump to the conclusion where it means that your FAB is saddle point, okay. And the last one, condition number 4, if your GAB is equal to 0, so they have no conclusion, no conclusion that we can make. Okay, they have nothing, or they have no conclusion lah, no conclusion. Alright. Okay, so this is the 4 conditions that you need to memorize. So what you should do is you just memorize the symbol lah, less than or greater than and so on. Okay. Alright. Okay, now back to the example. Okay, we back to the example now. So consequently, determine whether the critical point have a local mean, local max, or saddle point. So what we do? We find f as x. Okay, just now we already calculate, right? We already calculate your fx and fy. Okay, we already calculate. So now just extend it. So just differentiate it again, your fx. So it will be 6. And then fyy it will be 2. And then fxy it will be negative 2. Okay, done. Right, so now substitute into this. So AB here is a 2, 6, okay? Okay, substitute here. So 6, negative 2, negative 2, 2. So calculate it. So 12 minus minus will become plus. So it will be, minus. Okay, minus it will be 8. So this is your GAB. So now by using this answer and this answer, find out where is the critical point lies, whether it's a local mean, local max, or saddle. So you back to the condition here. So condition number 1 say that if your GAB is greater than 0, okay, you check. It's 8, right? So 8 here is greater than 0. And FSX AB here is 2, 6 lah. Okay, it's greater than 0. Is it greater than 0? Yes, it's greater than 0. Therefore, your FAB is a local mean. So you need to write here lah. Okay, you need to make it a conclusion. Your GAB or G26 is equal to 8 is greater than 0, and your FXX26 is equal to 6, which is still greater than 0. Therefore, your F26 is a local minimum. Okay, so this is the answer. Okay, alright. Okay, now we proceed with example 2. Okay, the same example that we have done before in the previous video. Okay, mana example 2 saya? Okay, example 2. So this is our example 2 just now. Okay, same thing. I will extend this equation. I will extend this question. Okay. Okay, then, determine whether the critical point have a local mean, local max, or saddle points. Okay, alright, so this is the example just now, the question just now. Okay. Okay, and this is our critical point that we get just now. Okay, so I just write first the critical point. So the first critical point is 1, -1. Okay, and second critical point here is -2, -4. Okay, so we do it for the first one first. Okay, so find out your f as x. What is your f as x? Just now you get your fx is y plus x squared, so that means your fx is 2x. What is your fyy? Fyy is -1. Okay, what is your fxy? Your fxy here is 1. Okay, so it will be same lah. Okay, sama lah kat sini yang this 3 and this 3 will be equal. Okay, alright, so maybe just consider as 1 lah. Okay, so I just write here your GAB now. So your GAB here is 1, -1. Okay. Oh, okay, sorry. Okay, this one supposedly, okay, if you can see that they have a value, right? They have an unknown x, right? So what we supposed to do is we need to replace this one. Okay, you can replace here, but since I said just now this one will be also implement or we will also apply to here, so I think we hold it first. Okay, just remain as 2x first. Okay, just remain as 2x. Okay, so just substitute here 2x 1, 1, -1. Okay, so what we have here, -2x minus 1, is it? Okay, now it's the turns that we will substitute this x. Okay, this is the time that we will substitute this x. So this x is referring to this x. Okay, this x is referring to this value, which is 1. So you just substitute 1 here, so you will get -3. Okay, -3. Okay, now we go to the second one. Okay, second one. So this one will be equal lah. Okay, fx, x you sama je lah. 2x, -1, 1. Okay, so now g -2, -4. So 2x, 1, 1, -1. So just now you have here, right? Okay, so this x, okay, this x we will replace with -2. So it will be 4 minus 1, it will be 3. So these two. Okay, so now you need to find whether this point 1, -1, local max, local min or saddle, and you do it the same thing for this point as well. Okay, so for the point 1, -1, okay, your g1, -1 is equal to -3, which is less than 0. Therefore, f1, -1 is a saddle point. Okay, it's a saddle point. Alright, then for -2, -4, since your g -2, -4 is equal to 3 and is greater than 0, so now you need to check your fxx lah. Your fxx -2, -4 is equal to what just now? Okay, fxx here is 2x, right? So now you just substitute x here with this value. So it will be -4. And -4 is less than 0. Therefore, your -2, -4 is a local maximum. Okay, so dekat sini -24. Okay, your fx here is 2x. Okay, so this x you need to replace with this x. Okay, okay, it depends on the point that you do now. Okay, kalau lah for example if 1, 1 here, so means that you will replace with x here is 1 lah. Alright, okay, clear? Alright, so now we are done chapter 1. So just I want to recall back that what we are learned in chapter 1. So the first week we learn about what we call the domain and range. Okay, domain and range, and then we go to the second one, which is limits and continuity, right? So limits and continuity. After that, partial derivative, total differential, chain rule, implicit differentiation, and this is the last topic, which is a local extrema. Okay, right? Okay, so hi. So we are finished chapter 1. So I hope that, okay, if you have a question, you can just ask me in, yeah, maybe in WhatsApp, or if you have a question for tutorial, you can ask your group member first. Okay, you group member first. After that, if no one that can answer your question, yes, you can ask me. Okay, class? Alright, okay, bye.